All right. Hey, everybody. Okay, so let's get started. Today we're going to cover adaptive management, and we're also going to cover specific techniques that can be used to manage forests for wildlife species. So let's start with the game bird of the day. Today's species is the Daurian partridge, and this partridge is named after the region in Russia where it's found. It's also found, as you can see on the map, in some other Asian countries, northern China. It's very similar in appearance to Hungarian partridge or chukar, which we've already talked about both those species. But the males have red eye combs near their eye, and they also have sort of a black horseshoe marking on their lower breast feathers. The males also have a beard of stiff feathers on the sides of their chin, which is very distinctive in the autumn and the winter. And this is a feature that's only shared with Japanese quail. Habitat, they like a variety of open habitats, so grassland, shrubby meadows, riparian areas where there's a river or stream and scrub, wooded steppes and plantations, as well as locally some semi-arid rocky hillsides with a little bit of vegetation structure. They don't really use true desert areas, even though they do live in semi-arid regions. They're somewhat mountainous. They can be found up to 3,400 meters in Kazakhstan. And as far as breeding goes, they lay anywhere between 18 to 20 eggs. The minimum found is usually 12. The female incubates the eggs alone, but both the male and the female care for chicks. Now, like a lot of the species we've talked about, which are found in Eurasia or the Middle East, there's actually quite a bit of missing information in terms of their basic biology and ecology. So we don't know a ton about this species. And you can think a little bit about why, we might have a hard time studying birds that are in those regions, just because access is difficult due to topography and geography, but also because in a lot of these countries they've been fairly war-torn. And so it can be difficult to study birds. Nobody wants to really go and do ecology in a war zone. So, all right, so a few announcements and reminders for today. So remember, the exam 2 is going to be next Wednesday during our normal class time. So you'll have to log on to Top Hat to do that. There's going to be a list of potential questions posted tomorrow on the 4th, which is a Saturday, and I'm going to select a subset of those questions to put on the exam. So it's the same format as last time, as exam 1. It's closed book, so you're going to want to be studying for that, and it'll cover all the material in the Human Dimensions module, including the material on Monday, which is going to be the finish of management techniques. So a reminder that the post-check questions for today's material are due by midnight tonight. And then there's also going to be an assignment on game birds abroad. So we were going to spend a whole day talking about it, but because they canceled class, this is one of the lectures that had to get deleted because we're shorter on time. So I'm going to have a homework assignment to replace that for you guys, which will be due Monday by midnight. So there'll be more detailed instructions posted on Canvas today. All right, so let's go into the material. So the material for today is adaptive management in wildlife conservation, and also specifically we're going to get into those management techniques for forests. So what is adaptive management? Well, the primary principle of adaptive management is that the decision makers, which in this case are the wildlife managers, need to learn from their management interventions, so from the actions they're doing, and they need to apply that knowledge in order to be more effective. So this is learning by doing, learning through experience. And the distinction between adaptive and adaptable is a special one case, right? So we don't want to confuse the term adaptive with adaptable. So adaptable is the ability to change through adjustment to currently occurring changes in whatever realm that you're considering, right? So that's a good thing for managers to be adaptable, but is not the same as adaptive in terms of adaptive management. So adaptive is instead a very rigorous very disciplined, stepwise process that we are consciously applying to our wildlife management, right? So this is a designed process where we're learning through our experience reactively. So these steps I'm going to outline should sound familiar because we did talk about them, but not in an adaptive management context specifically. So each of the steps below must be completed in order for your series of actions to be considered truly and legitimately adaptive management. So if you skip steps, you're not thoroughly completing them, it's going to inhibit our ability to learn from that experience. So adaptive management also, because of this, tends to require significantly more time and resources than what we consider sort of normal wildlife management to require. But eventually, it often pays bigger returns on investment, right? Because we're sort of learning through our experience and we're making necessary adjustments. So what are the steps? Well, the steps should be pretty self-explanatory, and we've sort of outlined them in a broad sense before. So number one is situation analysis. Number two is defining our objectives. And then number three is developing a model. These are sort of fitting into that kind of outlining your goals and information gathering steps that we talked about before. Number four, identifying and selecting alternatives, right? So if you have an objective, you need to look at all your range of options and weigh them against one another. Step five, monitoring the situation. Step six is implementing whatever your actions might be. And then step seven, one of the most critical, is to assess the results and how effective your management action has been, and then to adjust accordingly, right? Okay, so those are the sort of the steps. Here we can see a figure, and this is very similar to the word map that we did on the board previously, right? So you can see that there's a lot of arrows going all over the place. Stuff is very sort of integrated, related to each other. But we can see also that it's an iterative process. So this means that we're going to cycle through the steps multiple times to reach our objectives, and we're going to make adjustments. And we might repeat one step multiple times within one cycle. So, for example, we have a square here. See if I can get this so I can sort of draw. Maybe, there we go. So stakeholder engagement right here in the middle. And we might do that multiple times. We might cycle through that multiple times. We might have stakeholder engagement and model development, and then we might go back to stakeholder engagement again, and we might adjust our model, right? So it really is sort of a cycle process. Okay, so in summary, this was a really brief overview because we've talked about a lot of these ideas before. But in summary, adaptive management is a very effective process when we're dealing with a system that might have a lot of uncertainty. And we can learn from our actions and then adjust in order to achieve our desired results. Being adaptable is not the same as being adaptive in this context, right? So adaptive management requires adhering to this stepwise process that we've outlined. And you have to go through each step very thoroughly. Rigorous monitoring and assessment is particularly crucial because if we don't do a good job of those two steps, we can't learn anything. And that's what the whole adaptive management system is based around, is that experiential learning. We also know from previous discussions that stakeholder engagement is very crucial, and it's going to affect your objectives. It's also going to affect what alternatives are available to you, because your stakeholders might completely cross off an alternative as being acceptable to them. So we have that sort of public engagement going on in the AM process. Okay, so let's move on. Let's talk about some of the techniques that we can actually employ in management for managing forest species, particularly species of game birds, although most of this material is going to be applicable to any kind of wildlife, right? So there's a question on Top Hat, and that's going to ask you right now, what is a forest? Seems like a really obvious question, but as we've seen before in class, some of these things can be sort of hard to define. So go ahead and answer that question on Top Hat. Once you've answered it, we can move on, and I'll tell you what a good definition is. So a forest is a group of trees within a prescribed area. Now this definition is dependent on geography and perspective. So an urban woodlot can be defined as a forest. Perhaps in some places they would consider a Midwestern shelter belt, so that the tree rows found around crop or pastures, they might define that as being a forest. All the way to southern pine plantations or old growth forest stands of temperate rainforests in the Pacific Northwest. So all of these things can be classified as a forest. Okay, so successful forest management for game birds, really for any wildlife, is specifically linked to forest succession. And forest succession can be considered from a perspective of both plants and from birds. So there's two types. There's primary succession, and this occurs after a catastrophic disturbance sort of turns back the clock on our vegetation community. So the top image on your screen now is a lava flow had affected this area in Hawaii. So you can see that it's sort of bare soil and rock. And then you do have some scattered plants now that are sort of starting to grow up a little bit. So this is primary succession. This volcano completely obliterated the entire plant community. It burned through that rainforest, right? So that's going to be the process of those plants reestablishing, coming back, going through steps from maybe a few scattered shrubs to grass and shrubs, up to more shrub dominated, eventually up to mixed shrub and trees, and then all the way to trees. That's primary succession. We started with bare earth, basically. Secondary succession occurs in a plant community that remains after a less catastrophic event. So it's a plant community that has been altered in some way, such as a wildfire or through a timber harvest, which is what's shown on the bottom of the bottom picture of your screen. So to tell the difference between primary and secondary succession, we just ask ourselves the question, are there any plants left? If the answer is yes, you're looking at secondary succession. So there's still some components of the plant community available. If the answer is no, there are no plants left, you're looking at primary succession. That was a very strong catastrophic disturbance, and we've turned back the clock completely to bare rock or bare soil. Okay, so why is this important? We're going to get to next. Now, there is a question on Top Hat about succession. That's going to give you an example and ask you to figure out if it's primary or secondary. So go ahead and complete that, and then we can move on to the next slide. Okay, so plant succession changes the composition and structure of an ecosystem, and more specifically of the plant community. So early in succession, the shade intolerant species abound. So these are species that like a lot of sun, and there's nobody blocking their sun, so they do very well. But eventually, over time, these will be shaded out as more shade-tolerant species sort of grow up. And shade-tolerant species are usually longer-lived, and they're more competitive, so they outcompete the sort of sun plants, the shade-intolerant species. And we'll see a shift through these sort of steps of succession where we kind of early on think about it as being grass-dominated. Then we have some shrubs moving in to mix with the grass. Then we have maybe totally shrub-dominated. Then some trees starting to come up. And then we have pretty much all tree-dominated. And you can have sort of a secondary canopy, an understory, that kind of thing. But your species will change over time. Now, succession is important when we think about game birds because birds will key in on the structure of the plant community, which is inextricably linked to succession, right? So birds are not botanists. What that means is when they choose a habitat, most of the time, with some exceptions for very specialized species, but most of the time they're not keen in on a specific plant species. They're not saying, oh, I'm going to nest here because this is little blue stem and I nest in little blue stem. They're saying, I'm going to nest here because the cover is good to conceal my nest or conceal my eggs, right? So they're not botanists. They're not identifying a plant species and thinking, I'm going to use this. They're keen in on that composition and structure of an ecosystem, which is determined by where we are in that plant succession spectrum. So what that means for game birds is that depending on what game species you want to manage or to help proliferate in that crop, you will choose different management actions to either set succession back and turn back the clock or to allow it to proceed. Some species will also have special needs. And of course, geography plays a role too. So let's talk about this a little bit. So we're going to use bobwhite as an example here. Now, in Nebraska, bobwhite are considered to be a grassland mixed species. So they do require some woody cover. And that is their special need. They need some woody cover because that's what they use to hide from predators. So the plum thicket shown on your slide is mainly what I found bobwhite using in Nebraska as their woody cover. So that's a special need that they have. And those plum thickets, in association with grass, are going to be found in early successional habitats, right? So if we want to manage a forest for bobwhite, we're going to have to set succession back to that early successional stage, right? So how do we do that? That's where we're going. But of course, geography plays a role here too. Bobwhite in Nebraska use completely different habitat than bobwhite in the panhandle of Florida, where they're using open understory pine plantations. That's a totally different habitat. Could we plant a pine plantation in Nebraska? Maybe. It's not going to be very efficient. Maybe our soil's not right for it. We don't get enough rain to support that. So geography is also important. Okay, so that would be an example of an early successional game bird species. So if you want to target to proliferate bobwhite, you know you need early successional habitat. The opposite end of the spectrum would be something like wild turkeys. Wild turkeys actually like to use forest stands with fairly mature trees in them. Here in Nebraska, a lot of times that's going to be these shelter belts that line cornfields or pasture land. And so you're going to target that habitat if you want more turkeys in a specific way. So the idea with forest management is to tailor the forest to have the types of successional habitats that will attract certain species. Okay, so how do we achieve these differences in successional habitat? How do we manage for a particular species, et cetera, et cetera? Well, there's two main management actions for forests. Number one, prescribed fire, and number two, silviculture management, or management of the trees themselves. So prescribed fire in eastern North America, where there's a lot of forests, we know that wildfires historically probably occurred between every 50 to 100 years. But now, because we suppress wildfires, they occur approximately every 100 to 400 years. So that is a lot more time for these trees to grow and to become a mature stand. So that's a late successional habitat. And that's going to look very, very different if we're only having fires every 400 years compared to, say, every 50 years. In addition, fire is really important for regeneration of some species. So aspen and oak like fire because they need sort of that open area for germination. They need sunlight. Some species also require fire to open up their cones and to release the seeds so the seeds can actually germinate. There's species of pines that do this. Also, fire tolerant species have extra thick bark to protect them when a fire does go through. So some species certainly do better than others. So we can use fire to sort of tailor towards certain species and away from others, and to also determine our successional habitat stage. Prescribed fire has been very controversial, and I would argue that it continues to be, but it's very useful in managing vegetation and some forest stand types. So we can vary the size and the shape of the burns. We can target specific species of trees or shrubs. So we're using the benefits of a wildfire, but in a controlled setting. Mainly, prescribed fire benefits these early successional wildlife species, like many species of quail and partridge. Now, fire can be, primary succession, enact primary succession if it's an extreme fire. That's usually going to be a wildfire where there hasn't been one for a lot of years, and it burns so hot on a very hot fuel type where the soil actually can become sterilized. That's what we want to avoid. So if prescribed fire, we can enact secondary succession. So we don't completely wipe out the plant species, but we sort of turn the clock back a little bit, and we can benefit those early successional species, like many species of quail and partridge that require grass but also need some shrubs. This is a really good way to manage for them. Now, it can also, of course, have negative impact on the abundance or distribution of other species, like our upper canopy species. So we must know what our goals are and choose accordingly. So you need to specifically look at your objectives and ask, what species am I interested in producing more of? And you need to tailor your fire management to the needs of that, the habitat needs of that species. So then there's also these silviculture practices, and mainly dealing with the trees themselves. So the distribution of the trees, the size of the forest stand, the shape of the forest stand. So you're going to be sort of controlling that with either chemical treatments like herbicides or pesticides, either targeted where you're going in and removing specific species of trees, or you're just getting rid of a certain area, or a blanket application of herbicide where you're killing broader strokes of your forest stand. There's also forest stand management where you're doing mechanical removement. And there's two main forest stand management sort of categories. There's even-aged stand management and uneven-aged stand management. So of course, even-aged stands are composed of sort of a single age class of trees, and you can see that depicted in the bottom of the figure on your slide. So this produces a stand with trees that are all approximately the same age and size. It's going to be very homogeneous in terms of habitat structure. So this can be useful to benefit a very specific species or set of bird species. And this can be created through clear cutting and single time plantings. You plant all of your trees in a forest stand at the same time. They're going to be the same age. Now, clear cutting can have sort of a negative connotation to it, but it can actually be pretty useful in forest management if you do it carefully and you sort of shape your clear cutting size and location to your goals. For example, some species might want a little bit of an open meadow area within a bigger forest stand. You can create that meadow through clear cutting. Okay, so that's even aged. So then there's the opposite, the uneven aged, stands, which this has a much more diverse age of trees. It's going to be more heterogeneous in terms of habitat structure, and it's created through selective cutting or thinning. There's also something called edge feathering, where you basically go just into the edge and cut. So you're creating sort of a different successional habitat just on the edge of that stand. And this is really effective for bobwhite. On the edge of these forest stands, you can create that sort of shrubby environment that they need. Meandering edges are that you don't have just a straight cut. You're going to sort of make it a more complex shape. And you can also vary your planting times in order to achieve this uneven aged stand. Right? So those are sort of the two categories. There's a category in between called two-aged, where it's pretty self-explanatory. You basically have the even-aged, but with two different ages. So you do one planting, let those grow up, and then you later come back and do a second planting, right? Okay, so that's stand management. So kind of in summary, with fire and silviculture management actions in our forests, what we're actually doing is we're influencing succession, and we are acting as a disturbance. So we're replacing the naturally occurring disturbances with our own, which we have much greater control over. Any management action can be a single species model or a multi-species model. It all depends on your objectives. So you might want to decide, what suite of species am I looking at? Or if you have a species of, particular conservation concern, you can really target your management towards that one single species. So that's sort of the nuts and bolts of forest management techniques. And on Monday, we will cover grasslands and I believe sort of steppe habitats or rangeland habitats, and go into the techniques for those. So don't forget to complete your post-check questions, and if you have any issues, send me an email. All right, happy weekend, you guys.